how I got a job in the game industry, and all the talk was labeled being a graphics programmer. But when I started doing it, I realized there's probably a lot of people who are just trying to get in the game industry at all. So I'm gonna break this talk into two parts. First part, I'm gonna talk about specifically how to become a graphics programmer, or graphics engineer, because that's my background. Even though I don't do so much of that anymore, as much as I used to. And then I'm going to do the second half, just generally from an employer side, what we're looking for when we're hiring people and what you would do to get a career in the game industry from our perspective. And this is from the perspective of someone coming straight out of school. The assumption here is that you have no experience in the game industry. Once you have a little experience in the game industry, it's a completely different game than when you have none. This is what I just said here. All right, so who am I? My name is Dan Baker. I'm one of the co-founders of Oxide Games. I started my career back in 2000 when I was at Microsoft working on DirectX 8 and DirectX 9. And at that time, the industry was a lot smaller. Ended up making this development language called HOSL. How many people have heard of HOSL? A lot. Okay, I'm guilty one who made it. So anytime you bitch at it, that probably some bad or good reason 20 years ago that we had when we were making the language. I had no idea. No, I'm straight out of school. I'm making this language. There was two of us working on this language. Nobody thought it. And you're like, how the hell did you end up making this language? Well, in 2000, 2001, no one thought this was going to be a big deal or even necessarily succeed. And so, of course, you give it to the young people out of college. Like, make a language, right? And no one expected it. And it ended up turning into this big thing. After I worked at Microsoft for about 6 years, I went over to Firaxis Games and worked on a bunch of games there. Built the tech out for the Civilization series, led the graphics tech for Civ 5. Did a bunch of state-of-the-art DirectX 11 stuff. Always like being on the bleeding edge is what I'm used to. And then I co-founded Oxide Games 2012, and a bunch of new firsts. Made the first one of the first Vulkan and DX12 titles. And current game we're working on is Ara History Untold. It is launching September 24th, so it's on. If you guys have a chance to go to the madness that is Gamescom, you can play our game on the show floor. Hopefully, you'll be reading all about it in the coming month. All right. How did I start? Well, I went to school in the late 90s. Yeah, I'm feeling old. And when I went to school in the 90s, the idea of getting a job in the game industry was sort of like becoming a professional baseball player or something. It was like, or an astronaut. It was something that like you didn't seem like there was any fathomable way or program. You just had to know someone who knew someone. And I don't even think it was really what I thought I would be doing. I mean, as a kid, I was dreaming about it. I didn't even really think it was necessarily what I was going to do when I graduated college, but, was able to do that. The industry was just so much smaller then. And you can sort of see a timeline there of revenue in the game market. You can see the great ET debacle, if those of you don't know, and the great Atari debacle. And then it's just slowly expanded. But that's where I started my career in the PC game market in particular is much, much smaller. The industry has changed a lot in 20 years. One thing that has changed is this. When I started, PC industry is dead. No, it's really dead. The consoles are going to take over. No, it's really dead. Now it's all Facebook games. No, it's dead for sure. Now it's all iPhone games. And then finally, and I saw it this year, people were like, oh, wait, PC actually was the fastest growing market. There's something in this. It's like, yeah, really. It's been 20 years. So that's changed. People are actually finally really looking at the PC game industry and saying, hey, this is a real industry. So that's satisfying for me. So one of the questions that people ask me is, why did I personally get into graphics? So back up, how many saw the original Jurassic Park? So a lot of you have seen it. Now, I saw the original Jurassic Park. I don't know how old it was. I think like I was 12 maybe. And I remember very distinctly because at that time, there had been other movies that had done computer graphics before. In particular, how many of you guys have seen The Last Starfighter? All right, you're not allowed to be a graphics programmer unless you watch The Last Starfighter. The Last Starfighter is the first movie that really used extensive use of computer graphics, right? Massive numbers of scenes. A little of a trivia question. What was the first movie to use computer graphics? Does anyone know? No. No, it was Westworld. 1977, if I remember correctly. Hugh Brenner, the original Westworld, not the new one. And there's a scene in it where they make the vision of the robot and they digitize an image. And so it's the only effect they did. It was really simple effect. That was the very first one. I always like to throw that one out there because it's been a while. But when I was 12, the perception I had of Last Starfighter, and I was so young when I watched that movie, I was upset that I didn't see the previous ones because it was the last Starfighter. I didn't understand that the word "last" had multiple meanings. And that was done in a cray, very inspirational movie. But at that time, it sort of felt like, oh yeah, of course you could do spaceships and artificial things, but the concept of doing a biological, like a living thing, was like a fantasy. Like computers couldn't do that. They can do spaceships, fine, but you couldn't do that. And I was really blown away by watching Jurassic Park and actually seeing, oh my goodness, these dinosaurs are coming to life. And there's a scene where Tim Murphy's surviving because the velociraptors can't quite see him, and I think it's because they didn't have enough computing power to see the reflections correctly. Right. So when I went to school, one of my friends who later ended up leading the graphics for World of Warcraft, he had this great quote. I always like to say it. He thought someone's success in being in the game industry was inversely proportional to their grades. And what he meant by that was that when people would come and interview, no one really cares. I'll tell you right now, we barely care what your grades were in school. I'm not saying fail out of school. Just don't fail out of school. And the reason why he said that is because the students who were coming out of the school the best were the ones who were spending all their passion, all their weekends, all their late nights, like making demos and games from scratch. And those are the people who were very successful. And of course, if you're spending all your time to do that, you're probably not getting the best grade in, advanced French literature or whatever requirement you had. So it would drag your grades down. And at that time, you couldn't really do 3D graphics on your PC. Now, it was actually changed by the time I started school and I ended. You had to work on a Silicon graphics machine. These very expensive $10,000, $20,000 machines. So you had to be in school just to do anything on graphics. But by the time I had graduated, that wasn't true anymore. TNT, the 2 had come out, the GeForce had come out. You could buy a $200 graphics card and do real graphics on a PC. The whole industry changed in a very short amount of time. And when I was in school, there was a student-created group called BUG, the Boston University Graphics Group, and became involved in building our own game. We never really finished the game, but we built a game from scratch. It was a fighting game. But I learned a lot and was able to do a whole bunch of stuff. And it's interesting because a lot of the people in that group, like the Boston University Graphic Group, it's funny. They often went off and pop up in the industry all over the place. I don't even know. One of my friends, Natasha, is now the CTO of Activision. To show you that little group of people, where it was sort of unbeknownst to me, ended up being a very influential part of the industry. And unbeknownst to me, these non-class projects are actually what got my first job. So in 1999, I interned at Microsoft. And this was sort of an accident. I mean, just had a chance. One of my friends had gotten an internship there, and I had I had a meeting with the recruiter who somehow got me an interview on the DirectX group, and I didn't realize how hard that was to get. I'm glad I didn't. I made it nervous. And I just remember the first day I show up in the DirectX group, it was 1999, and I get to my boss. I'm all of 20 years old, maybe. And on my boss's desk is this open board computer circuit thingy. And it was just a PC that booted in 7 seconds in a GeForce 2. And I asked him what it was. He said, oh, that's just this thing called an Xbox. We're not going to call it that. That's just our code name. and I told him, I think it's a good name. It was my opinion. And he disappeared. And then, wow, it was really weird in my life to have been there when the very, very first Xbox. And he was super busy. My boss was so busy, like he barely had time to talk to me. Like I talked to him like once a week. I mean, literally, he was that busy because he was working on this Xbox thing. And I didn't know if I was doing well or not because he gave me this assignment to do some spline and tessellation stuff. And I got to the end of the thing, and he absolutely loved me. And I realized the reason why is because I was able to be productive and get this whole thing done that he assigned me and I didn't need a lot of help or guidance. I just did it. I didn't realize now in retrospect, I realize what a valuable thing that was. But, from his standpoint, that's not the expectation of someone coming, not even graduating school, to be able to given a fairly complex assignment and get it done in a period and get the specification done. And he thought that was really amazing. And so that led to a full-time job in 2000. So in internships here, like getting an internship is probably the best way to get into the game industry. And what you have to understand about an internship is an internship primary purpose is a 3-month job interview or 2-month job interview. That's what it really is. I have seen in my career people coming in arrogant and don't take advantage of this and are lazy and not doing the work. And it's like, what are you doing? Like this whole thing is an interview. Like if you're getting an internship, you really, really need to put everything into it because they are spending their whole time evaluating. And that's one of the best predictors of success of an employee is to see how well they do in this internship. I had a degree in computer science and a minor in math. I actually was only one class short of a major. I should have gotten it. But at that point, I knew I already lined up the job at Microsoft. They frankly gave me a full-time offer at the end of the summer. They said, we're going to hire you full-time. You just have to actually graduate. So, you can imagine senioritis when the only thing I had to do was get a C or passing grade on a couple of classes, and I knew I had a job already. I wasn't really that motivated to spend a lot of time finishing up a degree that would never matter. But I will say that if you're going to do computer graphics, getting some sort of minor or dual major in math. In fact, I would recommend almost getting a minor in CS and a major in math if you're going to do computer graphics. I mean, math is incredibly valuable for any game development to the point where the reason I say that is that you can study other things on your own. You can study computer science and you can study game design on your own. Math, you can, but I don't know a lot of people who've been super successful at teaching themselves math, and I don't know why. I think it's just it's matured over centuries at this point, and it's just hard enough where I think you need that class structure to force you to do it. And I never regretted any of the math that I took in my career. And meanwhile, a lot of the computer classes that I took, everything I learned is completely obsolete now, and it's just the way it is. So getting a job in graphics today is a difficult job to get, but not for the reasons you think. In 2000, it was highly competitive. So if you knew any graphics knowledge, you were just begging someone to take you. In my case, I got the DirectX scheme. They liked me, and I was able to get a full-time job. And that was the reality in 2000. In 2024, if you are good at computer graphics, I just feel like you will not be unemployed. Because the demand for people who know how to do this is really high. The problem is it's an enormously difficult skill set to get. That it takes at this point that when I have advised people to get a job in the computer graphics, and even when we're hiring, I'm saying at this point I expect an entry-level graphics position to have a master's degree. I don't think that you can start a job in graphics with just an undergraduate. I did when I did it at my time, but I also had a double degree. At this point, I don't think you can do it. There's just too much. You have to spend 4 years just to get to the point of you getting the prereqs to really get into the advanced stuff. And one of the problems is that there's also a ton of sub-branches of graphics. I mean, I started as oh, you're a graphics person, but now it's well, within that domain, there's all these subfields. There's graphic systems, optimizing CPU side code, graphics compilers, language shader, animation, rendering, tool pipeline, AI. AI is 90% the same as graphics, 95% the same as graphics inside the domain. It's basically the first two of those things. That's why so many graphics people and AI interchange. And so when you're looking at all this stuff, you have to sort of pick where your specialization is going to be, or be skilled at more than one of them. I'm pretty skilled at systems, compilers, rendering, but not so much tool pipeline, animation. And I know some things about AI, but I haven't been doing a ton of AI. And one of the reasons it's so complicated is that when I started in 2000, GeForce 2 was about 25 million transistors. The term GPU didn't even exist. Like graphics processing unit was a marketing term. I think I don't remember if it was coined by ATI or NVIDIA in the early 2000s. Once they started becoming programmable, I don't remember what they called them. They just sounded like graphics chips or a graphics card or something, right? And then in some marketing, someone said, "Oh, it's a GPU because it's like a CPU." And everyone, of course, it's a GPU, right? But it didn't even exist, the term, when I started my career. I looked this up. The transistor count of a 48 ATI is 76 billion transistors. So you could fit, 3,000 GeForce 2s on it. And just to give you an idea of how incredibly complicated one of these devices is. These things are so incredibly complicated that even if you don't know anything about rendering theory, just the skill to program this thing is incredibly valuable. And that's what an AI engineer is effectively doing. Just they're taking this chip and understanding how to program this massively complex things. And they're so complex, you're seeing emergent behavior in them, like, can you know what it's doing? Well, you have to sort of instrument. It's like becoming organically alive. And this will feed into another subject I'll talk about in a bit, where I feel like there's a big deficiency in schools. So staying into the concept of, like, I would say, well, how to hire graphics people? I've hired quite a few graphics people over the years, and what am I looking for? And the first step is just a general engineering test. Well, one of the things about being a graphics programmer is you have to be a really, really strong programmer. You can't cut it if you're not a strong programmer. Ironically, you may not be writing a lot of code, but it's just incredibly difficult. So if you can't pass, or not just pass the engineering test, we actually give a test, but just do really well in it, we're probably not even going to consider you for a graphics position, because that's just a prerequisite. And of course, there's good old whiteboarding, the problem. And the next step after you pass that is to suss out, like, okay, what do you know about GPU architecture and rendering theory and multi-core system knowledge? And we suss out. I don't expect someone coming out of school to know these things well. Like, if you knew these things well, you're a senior level graphics person. But I've been surprised at how many people have almost no knowledge of this. They took like one graphics class in college and like, oh, I do graphics programming. Like, well, okay, I've got to spend a couple years teaching you this stuff. And these are the areas that you really want to be looking at. Realistically speaking, not only would I don't require you having a master's degree. I just haven't hired someone without a master's degree in graphics in 10 years. The only exception that we have one person who transitioned from internally to a graphics position, and I said, okay, you can do that, but I want you to get your master's. And so he's been working on his master's. And a few of our graphics engineers are currently working on their PhD. There's no way you can do graphics without having vector calculus. I recommend advanced calculus, statistics. Some people ask, what about physics? You can take physics. I just feel like physics, when I started taking physics classes in university, I actually quickly stopped because it was 85% the same as the math class, and it was just doubled up on it. So I don't think taking physics is necessary if you're taking the vector calculus. So like you can take one or the other. There's so much overlap in those. All right. I asked all my graphics buddies when I was doing this talk, I had this bail. I was like, what resources would you recommend for people if they're getting into graphics? And so I got this massive, there was more than this massive list of sites, and I'll try and put these slides up online if I figure out how devcom can put them up. But there's one of the problems with computer graphics is there's not a lot of books. How many people? There's the real-time rendering book. How many people have that book? Well, a few of you. That's not a textbook, though. The real-time rendering, I actually reviewed a few chapters in that book. The real-time rendering book is a reference book. You can't really read that cover to cover. In my opinion, there is not currently a appropriate textbook that would teach you how to do graphics. There are books, but they're either old or obsolete or very academic. They're not really going through the level of like how a current GPU is working, the current state of the art. And so you have to cobble it together from all these different sources. In particular, we don't teach in university, except a few people do, but it's very rare, GPU architecture. GPU architecture has to be sussed out through all sorts of random sources. There's not a guidebook, and GPU architecture is incredibly useful, and there's basic knowledge. And the reason I say it's important is it's incredibly unintuitive and counterintuitive when you're looking at a GPU about what's optimal or not. Like, if you think you understand what's fast and not, you won't, and if you do, it will be not correct 5 years later when the GPUs work a different way. and it may even be different from one GPU architecture to the next. It's just they're so complex and so unintuitive until you really dive into it. And I really recommend understanding how they work. It is a very different world than a CPU. All right, so that ends the first part where I'm just talking about graphics. I probably should have done it the other way, but it's the order I made the talk. So this is more general and like when we're hiring people. So I made my own quote, which is probably bad form, but I always like to tell people the game industry is not a job for the lazy. And I say this because I have seen people trying to get into the game industry and they don't have the work ethic. And it's just not a good place to be. It is a very difficult industry. It's one that requires a lot of dedication at times. So if you want an easy job or work for a bank or something else and play games on the side, you'll be happier. One of the things that I've seen is when I started, the game industry is small and there weren't colleges that taught like game industry. There was no such thing as a game industry track. Like if you had asked the college if they had a track, they'd look at you like you're crazy. But now there's an entire industry just built around educating it. And it's as much of a business as the actual game industry. And in my opinion, I hate to say it, but a lot of those schools are making money off selling you a dream of getting in the game industry. It's not like they don't have good classes and good material and stuff, but the reality is that they're there to take the students' money and promise you that you can get a job in it, and it's not necessarily the case. And they have a very strong emphasis on the fun parts of being a developer, or the perceived fun. I say perceived fun because what's fun is different for every person. On things like designers and writers and all these various things, of which we're just producing way too many. The industry doesn't need that. All right, so what's going on in the game industry? So a lot of you are thinking, okay, what do I want to do in the game industry? What's my guidance for what I see? The game industry is maturing. Job descriptions are becoming a lot more defined. There's like, I'm a texturer, I'm a rigger, I'm an AI programmer, these, gameplay programmer. It used to be everyone was a generalist, and that's becoming out. But so the good thing is it's a little easier to understand what the job requirements are. So a lot of these universities are correct in what they're teaching people is what that job is. The bad of this is that many positions are becoming commoditized. In particular, audio, animation, modeling, concept, QA are becoming increasingly commoditized. And AI is taking over many of these Monday tasks. And what I mean by commoditized is that, we're in the part of the Western world, Germany, France, anywhere, most places in Europe, in America, our wage salary, or what we call our blend rate, is way, way higher than other parts of the world, like Eastern Europe, South America, Asia. And so a lot of these positions are becoming more defined, and with technology, they're becoming easily contractable outside. So these are harder and harder jobs to get high salary jobs in the Western world, because a lot of it gets outsourced. And just we have to be aware of that. So that's kind of the negative thing. And the basic trend is that when you're looking at a job, it's really, I think, a simple metric. The more difficult the job, the harder it is to get commoditized. The easier the job is, the easier it is to get commoditized. And so you want to pick jobs that are technically challenging and difficult and become expert in them. You'll be fine. But the reality is, like, if you want to be a writer for a game studio, good luck. Like, that's just an incredibly high hurdle. Or even think like a concept artist. Yeah, between concept art is becoming incredibly difficult, because between AI and the fact it's actually relatively easy to outsource to Asia or South America, those aren't the best positions to be in the Western world. And one of the reasons too is that you have a lot of these. So AI generated this image for me. It was cool. I asked it to make a factory of a university, and it made that. But what we see as an employer is that there are these various academics, universities are spinning out a lot of graduates. And a lot of times these graduates have just completely unrealistic expectations. We've had a few game design interns who thought they should be able to design the whole game or their idea. And we're like, well, know. I mean, you just came out of college, and so you have to really understand what is wanted. And there's two little applications for harder positions like a technical artist. I have a slide here. These are not in the right order. So when we're initially hiring people for any position, obviously we're looking for the best people. We want people to be passionate, professional, and we really are looking for people who are both versatile and able to learn, and also really committed to being excellent. Too often, when you get to the non-fun part, but the problem with the games is that 10 to 5% is really, really fun, and the other 90% is grueling hard work. And we need people who are willing to do that 90% grueling hard work and committed to being excellent, not just that 5% fun part. And a lot of times people will skip over that grueling hard work and only concentrate on that 5 or 10%. So there's sort of a joke in the game industry among anyone who's been there for a while, is how much we don't want to hear about your game idea. There's a whole Reddit thread. There's whole Reddit threads about the idea guy, and the idea is people are always talking about their amazing idea for a game. I'm sure every single person here has a great idea for a game. And in the game industry, I hate to say it, we don't care about people's ideas because everyone's got great ideas. Ideas are not the problem in the game industry. The problem is doing the idea. And so when you get the kind of a disconnect where someone says, I've got this great idea for a game and that's what's going to get you a job, that is really not a good approach. For most people professionals in the game industry, if you come to them and say, I've got this great idea for a game, well, immediately everything you say after that, they didn't hear. They like immediately will shut off. Like it's just a word of advice. There's a whole Reddit post on this stuff, and that was largely very amusing for people who've been in the game industry for a long time. All right, this is illustrative only, so please don't quote me in this for like a research paper on actual data. This is my rough impression of some of the positions that we've seen for like how many positions that will have versus how many applications that, and mind you, this is already pruned off for qualified. By qualified, I mean, do they even have anything remotely resembling a resume that we would even do an initial phone screen for? And you can see kind of the mismatch in the positions. Junior game designer is so bad when we put a junior game designer position up that what we had 300, 400, 500, we had to like, one of our designers, somehow someone found out her email and she had to change her email because she was just getting so many emails from people. And the truth is that probably many of them were good. I mean, I don't think that they're necessarily bad and probably could have done the job. But when you're an employer and you're looking at, you put a position up and you're getting 300, 400 applications. I just put 100 because it was blowing the entire chart out. Then like you can't even really read that many resumes, and so it just becomes, you're gonna be kind of lucky just to even get someone's eyes on it. So it is one of the hardest positions just because the sheer volume of applications we get. Meanwhile, you get a junior tech artist and we have like 4 applications or something ridiculously small, and so you can bet that we're gonna probably call every single one of them and schedule an interview, right? Most of them, right? And a programmer too isn't as bad. We get some number of them. We have an automated programming test, so typically we will, when we have positions, we'll reply to a lot of people. And junior artist isn't as bad as junior game designer, but is still, we'll also get lots and lots of applications. Do I have an slide? So I made a couple slides of the do's and don'ts. All right. So it's really important that when you're in school, you focus on the classes that are hard to learn yourself. Don't focus on the classes that you can learn yourself on YouTube. There's tons of YouTube videos on how to like make a game in Unity. There's tons of YouTube videos and all sorts of stuff. YouTube's amazing. Like you can get entire education in YouTube. What you really want to do are pick the classes that are hard to just read an article or watch a bunch of YouTube videos on. Something that like you're going to get your money out of being at the school. I point to things like compiler theory, OS classes, graphics classes. Those are typically good classes to take. They're hard. It's a theme here. The hard classes are the ones you want to be taking. C and C++ development skills in general out of school are very weak for almost every person. I don't know what it is about where teaching C and C++. There's teaching a lot of theory, but most of the time you're not writing code from a spec with like over these overly complicated object-oriented stuff. You're debugging massive code bases. And so debugging skills and what I call instrumentation skills of understanding that the problem that you're going to approach is going to be so complex, you need to build what I call it scaffolding, which is infrastructure in your code just to try and diagnose where your problem might be later. Because any program that gets more than a few thousand lines, you're going to have bugs in it, and you need to be thinking about that from day one. And that stuff is generally not taught in school. There are some really good channels. How many people have heard of Handmade Hero? Gary, great series. Casey can be a little bit of a, I don't know, he has sort of a interesting personality, but he has his very good points. A lot of his points are very valid about especially the kind of standards that we expect in the game industry and how different they are. Watching the whole Handmade Hero series is a fantastic way of almost all the programming advice he gives. I agree with 90% of it. 10% I don't, but 90% I agree with. Next big advice I tell people is build a game from scratch. Don't use Unity or Unreal game. And the reason is really simple. We can't tell when someone makes a Unity Unreal game what you made or not, because there's so many plugins for them. It's very easy to slap something together, and we have no way of assessing what your skill is. I would rather see someone come in having built just a replica of Tetris from scratch that they did than see an amazing game with Unity or Unreal, because I won't know what you did. Whereas with a Tetris game, I know that you can take something from scratch, and I have a good evaluation point of what you can actually do. Be humble. Usually this isn't a problem. Usually people are just so happy that a game industry, a game company will call you and you can interview, that they're just really excited. But every now and then we get someone who's just telling you how bad you are at your job and how, coming up with this very arrogant thing. And of course, I don't know if they know they're doing it, but you're just sort of like, okay, man, I've been making games 20 years. I can, calm down. You don't have any experience. So with the don'ts, you'd be surprised how many times in my hiring process where we've liked a candidate, and then we investigate their resume and they did something, they bullshitted something, or they claimed something they didn't do, or it is not super frequent, but it's surprising how many times like we would have hired them had they not basically lied on their resume. And there's nothing more tragic than that. You should never lie or embellish on your resume, because we do investigate. Not every employer is as diligent as we do. We do that. We do references. We call people. It's one of the most valuable things we do. So if you do this, we could have loved you, and then we find something in there and it's an instant no, we're not going to hire you. So never do this. Don't have irrelevant jobs on your resume. This isn't a deal breaker. I just see this all the time. Like, I don't really care if someone worked at Burger King when they were 16. Like, it's just, if you have some hobbies and stuff, definitely put them. Just don't put a lot of space on them. And unrealistic expectations about salary responsibilities is also something coming in. The other thing I will say a lot is, they do this all the time in your courses, and your professor will give you a nice assignment to do this thing. It's great. They're fantastic. We don't want to see them as demos as your examples, because everybody's doing exactly the same assignment. I can guarantee if your professor or your class has an assignment, that a bunch of other people are going to be submitting something very similar, and they're probably better than what you did. Right? So we see that all the time, and it also doesn't show that you have initiative. So I'd much rather see something you didn't do as a class project. The class projects are fine, but that shouldn't be your primary, your thing doing it. So I like that universities are telling you to do that, but you need to do more than that, because everyone's got that. Like, and because they're so structured in the class, again, you have the same problems. I don't know what you did or how much the professor or the class structure just helped you get this goal. So it becomes not a really great metric for us to see that. All right. It's my last slide before questions. Great. right on time. Go into a position where there is demand for. This is probably the best advice I can give you. You want to find a position that there's a lot of jobs for. Sounds simple. In my opinion, no matter what position that you want to be in, if you want to be a writer, if you want to be an animator, or if you doesn't matter, you should show that you have the ability to write a code. So if you're an artist, I guarantee if an artist comes in, artists always come in with the wrong thing. If they came in and they had this great, decent portfolio, but they also wrote a Python script to automate their entire animation rig, I'm going to hire that person. That's amazing, right? And not every studio is like that, because that's very typical. And we have so many assets and stuff. Being able to get clever with your tools and fix problems is a big deal. Or a producer who's, again, able to write basic scripts. It doesn't have to be heavy coding, just ability to really get in and understand what's going on. If you want to get in development, the best advice I have for someone, you want to impress me, you come in and you implemented an entire game, a simple game, 2D game, doesn't matter, but you did it from scratch, and it's a nice little game. That's going to impress us. We rarely see that. It'd be amazing how rare we see someone come in with a game they built from scratch. We'll see all these Unity games. They're all the same. It's just so unusual for actually somebody doing that. One of the things too, embrace AI. Now, why do I say this? We've had a lot of people, even employees, who are very hostile to AI. A lot of these machine learning techniques. And the truth is that AI is just a tool like anything else. We do a lot of it's more traditional AI, not like new machine learning stuff, but it's a tool like anything else, and it is the future, and we're going to use it in all sorts of weird ways that we don't know about yet, and it's something that should be in your back pocket. And then finally, and I've got this in sort of bolded, is having realistic expectations about the game industry. The game industry is a magic place. It is wonderful. It's fun. But it is a hard, difficult business. And it's a hit-driven industry, and you have to have a thick skin and perseverance for it. That's just an absolute essential. It is not an easy job. It's better than it used to be, but that's just something you have to be in the mindset for. If you are not resilient to that sort of thing or not willing to accept it, then you should probably rethink it. And this is why, by the way, you see a lot of people after about 20 years in the game industry will leave. Very common. About a third of my friends, after doing games for 20 years and they've shipped a lot of successful titles, are like, I don't want to deal with the instability and the stress and all that. And they're like, I'm done with it. So that's why it's pretty common. And that concludes the talk. And now let's open it up to questions, because we have about, how much time do we have?
10 minutes.
10 minutes. We have 10 minutes.
Thank you very much. I have a question regarding tool development. What are some traits you look out for in junior or mid-level roles?
Can you repeat that?
Yeah. What are you looking for in tool developers?
Tool development?
Yeah.
That's a good question. Actually, to be honest, no one applies for a tools job. No one wants to make tools. So the moment someone applies for tool jobs, they're like, well, we're going to interview them because, for whatever reason. So that's probably number one thing, is just saying, hey, yes, I'm willing to work on tools. Okay. The second thing is, tools can be very pragmatic. One of the things that, how many people have used DRM GUI? Oh yeah, DRM GUI is awesome. So being able to show that you've written some tools and various other things is what we're looking for. And people generally, probably the biggest thing for a tools person is willing to realize it's important. And also a good personality, because tools people have to work a lot with a lot of different people, and they have to be really thick-skinned to being yelled at all the time when the tool's busted, because the tools are always busted.
Thank you.
Yeah, thank you very much for the talk. It was very interesting. I was wondering how you would personally describe the difference between when you're looking for programmer roles and when you're looking for tech artist roles.
Oh, that's a really tough question. All right, a tech artist and a programmer are so nebulous that we've had people switch roles in our company from a tech artist to a programmer. because really there isn't a very delineated line between them. I think the difference is this, that a programmer is an engineer, and they're building a big complex system from the ground up, whereas a tech artist is a programmer, and they're writing a lot less code. They're not necessarily writing big systems, and they're writing little pieces of it, and also have a lot of art skills to combine. But it's definitely a very fluid position between the two of that role.
Thank you.
And I think it's going to get even muddier with AI. I think you're going to see a whole class of people who are building, like, and they're doing AI, like especially synthesis stuff. You're going to see people who are like really in between.
Thank you for the talk. There was on the last panel something about libraries. So while applying, how in depth should, like, for example, such libraries, for example, extensions on physics or graphics, how much do you expect it to be like detailed, or is it more of like showing off that you know what to do in generally?
Well, yeah. So when I say, I mean, obviously, if you're doing something, you're going to have to use some sort of library. I mean, like even if you're doing graphics, you're probably not necessarily writing straight to the metal in all cases. The problem is that it's too easy with all these free open source and things out there just to bolt a bunch of libraries together. There's just so many plugins, and so it becomes impossible for us to know what you did, which is why it's just easier if you use as few as possible, because then it's just a lot easier for us to evaluate, okay, I know what you did, especially because we do like looking at source code. Like I really like it when, so when somebody gives us an application and then they give us a link to their webpage where, now I know not everyone does this, but we do this, and then this is the project I work on, and here's the code. Yeah, our guys will go to the place and they'll download your code and they'll look at it, right? Like we do. And so the more code that you've written, and so when you look at someone's code and all they've done is like glued a couple middleware together, we're like, that's interesting. But when I go to the code and I say, okay, there's some real substance here, then yeah, we notice that. And not everyone does that, but at some of the better places, we do actually spend some time looking at what you did.
What's your opinion on SDL, and have you followed the development with SDL GPU? Just out of curiosity.
I don't know enough about to have a super strong opinion. Sorry.
You said that you sometimes look at people's code. Do you also look at people's version control, how they do the commits and how they name them and that kind of stuff?
I mean, we might, but honestly, like, we don't really expect people to have good discipline on source control and their students. I mean, it takes years to learn that. So it's not something we extensively look at. We like the fact that people have used, like, Git's hard to use, honestly, but we like people have used it, but that is definitely not something that we would have a problem with if someone didn't know that well, because that's very specific to the particular environment that you're in, how people do integrations. Lots of questions.
Hi.
Good.
You referred that you also employed a member for graphics that already worked on a company, and you've been told that you should go back to school and have a master's. But
Yes.
In those situations, what do you think is a good strategy to have like an internal shift from, let's say, gameplay programming to computer graphics?
So in the case of us, it was actually, we had someone we hired for a tech artist, and they said, I know, Dan, I really want to do the graphics. And I said, okay, but there are holes. There are holes in your knowledge, and I work with them enough time. And so I said, we'll move you around, but I want you to go to school to get your master's to finish those holes off. So that's how it works. So in our case, not everyone's like this. This is the way I am, because even though I didn't get an advanced degree in graphics, I have a lot of background in that. I have a lot of published papers and stuff. So I really dislike, me personally, people having holes in their knowledge. So I tell people, and it's really easy to happen if you don't have the master's degree or that background. Like, there can just be some random blind spot that you don't know about. And so it's getting that broad education. So my advice is talking to your manager and saying, hey, I really want to do graphics. What do I need to do? And a lot of times, like we actually will pay for a lot of schools. I don't know if it's like this in Europe, but a lot of places in America will actually pay for your schooling. Like when we send people, say, get your degree, we're actually pay them as long as they, get a B or higher. I don't remember the threshold is. You have to get good grades, but yeah.
Hi. So I'm not really part of the gaming industry. I have an embedded systems background. My question is about Vulkan. So in my hobby projects, I use mostly OpenGL, and my question is, do you think Vulkan, the complexity is worth for the speed trade-off?
As a student, are you saying, or just in general?
Yeah. So using Vulkan in a hobby project, I found it's very complicated. And
I mean, here's the thing with Vulkan and DirectX, having been in the committees designing some of this stuff, Vulkan is not hard. Graphics is hard. The reason people struggle with Vulkan is because you're not understanding how the system works yet. And so if you know how it works, it's not a problem. And so the reason why I think it's actually a really good idea to learn it is because if you go and you learn Vulkan, you learn a whole bunch of things about how GPUs really work. And that's the value in it, is just that ripping the Band-Aid off and understanding how the system really works.
Okay, thank you.
One more.
We got one more, and then I can stick around for a little bit. 10 minutes.
Thank you for the talk. I was wondering how, when you're hiring someone, how much, if the person has a background in open sourcing, doing like graphics programming in open source projects, how much weight does it have compared to someone who did, for example, just a master's degree?
So we're really looking for is someone who has the skills. So the master's degree in of itself is not like, oh, you get a master's and magically can hire you. The reason why I recommend that is because it's a good indication that you don't have, like, say, holes in your knowledge. Open source is a tricky question because, again, it comes down to the problem of that we're running into increasingly is like, I don't know what you did, right? Like if you can look at the open source and say you were the primary contributor, then it's a little bit easier, but it can get really hard to distinguish, like, okay, were you the person who actually did all this stuff, or did you just contribute to some other code? And so, part of the interview is just understanding what you did. And that's why I always emphasize that, like being able to clearly explain your contribution, because for us, it's all about evaluating your own knowledge. And I think that's it. And I'll stick outside for a few minutes before I have to abscond.